हॅलो फ्रेंड्स, राणा अकॅडमी या यूट्यूब चॅनलवरती आपणा सर्वांचे स्वागत आहे. आपण स्टार्ट केली आहे 11th क्लासची केमिस्ट्री, ज्यामध्ये आपण आतापर्यंत पाहिला सम बेसिक कॉन्सेप्ट्स ऑफ केमिस्ट्री. त्यानंतर आपण दुसरा चॅप्टर पाहणार आहोत, स्ट्रक्चर ऑफ ॲटम. चला तर मग व्हिडिओला सुरुवात करूया. तुम्ही या चॅनलवरती जर नवीन आला असाल तर प्लीज या चॅनलला सबस्क्राईब करून ठेवा, जेणेकरून तुम्हाला आमचे नवीन व्हिडिओज पाहता येतील. चला तर मग सुरू करूया चॅप्टर, स्ट्रक्चर ऑफ ॲटम. सेकंड चॅप्टर आपला 11th क्लासचा केमिस्ट्रीचा. The word atom has been derived from the Greek word atomio, which means uncuttable or not divisible. J.J. Thomson in 1898 proposed that an atom possesses a spherical shape, radius approximately 10 to 10 meter, in which the positive charge is uniformly distributed. The electrons are embedded into it in such a manner as to give the most stable electrostatic arrangement. Figure 2.4, NCERT page 5. Many different names are given to this model, for example plum pudding, resin pudding, and watermelon. Rutherford's nuclear model of atom. तर काही पॉईंट्स आहेत रदरफोर्ड न्यूक्लियर मॉडेल ऑफ ॲटमचे, ते आपण पाहणार आहोत. पहिला पॉईंट आहे, मोस्ट ऑफ द स्पेस इन द ॲटम इज एम्प्टी ॲज मोस्ट ऑफ द पार्टिकल्स पास थ्रू द फॉईल अनडिफ्लेक्टेड. सेकंड पॉईंट आहे, अ फ्यू पॉझिटिव्हली चार्ज पार्टिकल्स were deflected. Deflection must be due to enormous repulsive force, showing that the positive charge of the atom is not spread throughout the atom as Thomson and presumed. The positive charge has to be concentrated in a very small volume that repelled and deflected the positively charged particles. Calculations by Rutherford showed that the volume occupied by the nucleus is negligibly small as compared to the total volume of the atom. The radius of the atom is about 10 to the power minus 10 meter, while that of nucleus is 10 to the power minus 15 meter. फोर्थ नंबरचा आपला पॉईंट आहे, ऑन द बेसिस ऑफ अबोव ऑब्झर्वेशन्स अँड कन्क्लुजन्स रदरफोर्ड proposed the nuclear model of atom after the discovery of protons. According to this model, the positive charge and most of the mass of the atom was densely concentrated in extremely small region. This very small portion of the atom was called nucleus by Rutherford. The nucleus is surrounded by electrons that move around the nucleus with a very high speed and nucleus in circular paths called orbits. Thus, Rutherford's model of atom resembles the solar system, in which the nucleus plays the role of sun and the electrons that are of revolving planets. Electrons and the nucleus are held together by electrostatic forces of attraction. The number of protons present in the nucleus is equal to atomic number. The nucleus is equal to atomic number. Z is atomic number is equal to number of protons in the nucleus of atom is equal to number of electrons in neutral atom. ना आपला ॲटॉमिक नंबर कसा फाइंड आउट करायचा? ॲटॉमिक नंबर बरोबर नंबर ऑफ प्रोटॉन्स ऑफ द न्यूक्लियस ऑफ ॲटम किंवा नंबर ऑफ इलेक्ट्रॉन्स in neutral atom. Protons and neutrons are present in the nucleus are collected in nucleons. The total number of nucleons is termed as mass number. Of the atom mass number A is equal to number of protons plus number of neutrons. Isobars are the atoms with same mass number but different atomic number. For example, C14 and CN14. On the other hand, atoms with identical atomic number but different atomic mass number are known as isotopes. C614, C613, C612, chlorine 1735, chlorine 1737. Drawbacks of Rutherford model. According to the electromagnetic theory of Maxwell, charged particles, when accelerated, should emit electromagnetic radiation. This feature does not exist for planets since they are charged. Therefore, an electron in an orbit will emit radiation. The energy carried by radiation comes from electronic motion. The orbit will continue to shrink. Calculations show that it should take an electron only 10 to the power minus 8 seconds to spiral into the nucleus, but this does not happen. This Rutherford model cannot explain the stability of the atom. The frequency, wavelength, and velocity of light are related by the equation 2.5 c is equal to v lambda. Then other commonly used quantity, especially in spectroscopy, is the wave number v. It is defined as the number of wavelengths per unit length. Its units are reciprocal of wavelength unit, that is meter inverse. Hertz, performed the very interesting experiment in which electrons or electric current were ejected when the certain metals, for example potassium, rubidium, cesium, etc., were exposed to the beam of light. The phenomenon is called the photoelectric effect. For photoelectric effect, H nu is equal to H nu naught plus half v square. Planck's quantum theory: radiated or absorbed by the body are not continuously but discontinuously in the form of small packets. Each packet is called a quantum. In the case of light, the quantum is called a photon. The energy of quantum is directly proportional to the frequency nu of the radiation. E is directly proportional to VE is equal to h nu, where h is Planck's constant and its value is 6.625 into 10 to the power minus 34 joule second. The spectrum of radiation emitted by the substance that has absorbed energy is called an emission. Produce an emission spectrum. Energy is supplied to the sample by heating it or irradiating it, and the wavelength or frequency of the radiation emitted as the sample gives up the absorbed energy is recorded. An absorption spectrum is like the photographic negative of an emission spectrum. A continuum of radiation is passed through the sample which absorbs radiation of certain wavelengths. Line spectrum hydrogen. Next point, line spectrum hydrogen. When an electric discharge is passed through gaseous hydrogen, the H2 molecules dissociate and energetically excited hydrogen atoms produce and emit an electromagnetic radiation of discrete frequencies. The hydrogen spectrum consists of several series of lines named after their discoverers. The Swedish electroscopist Johannes Rydberg noted that all series of lines in the hydrogen spectrum could be described by the following expression: Bohr's model for hydrogen atom. The electron in the hydrogen atom can move around the nucleus in a circular path of fixed radius of and energy. These paths are called orbits. Stationary states are allowed energy states. These orbits are arranged concentrically around the nucleus. The electron can move only in those orbits for which its angular momentum is integral multiple of h by 2. That is why only certain fixed orbits are allowed an angular momentum of an electron in a given stationary state can be expressed as an equation m is Vr is equal to n dot h upon 2 pi, n is equal to 1 to 3, and so on. The energy of an electron in the orbit does not change with time. However, the electron will move from the lower stationary state to the higher stationary state when a required amount of energy is absorbed by the electron, or energy is emitted when the electron moves from higher stationary state to lower stationary state. The energy change does not take place in a continuous manner. The frequency of radiation absorbed by emitted when transition occurs between two stationary states that differ in energy by delta E is given by V is equal to delta E upon H is equal to E2 minus E1 upon H. Bohr's theory can also be applied to the ions containing only one electron, similar to that present in hydrogen atom, for example, helium positive, lithium dipositive, beryllium tripositive, and so on. The energies of the stationary states associated with these kinds of ions, also known as hydrogen-like species, are given by the radii of the expression. Limitations of Bohr's model: it fails to account for the finer details doublet, that is, too closely spaced lines of the hydrogen atom spectrum observed by using sophisticated spectroscopic techniques. This model is also unable to explain the spectrum of atom other than hydrogen, for example, helium atom, which possesses only two electrons. Further, Bohr's theory was also unable to explain the splitting of spectral lines in the presence of magnetic field, Zeeman effect, or the electric field Stark effect. Dual behavior of matter: the French physicist de Broglie in 1924 proposed that manner like radiation should also exhibit dual behavior, that is, both particles and wave-like properties. The de Broglie relation state that the wavelengths associated with the moving object or an electron is inversely proportional to the momentum of the particle. Lambda is equal to h upon mv is equal to h upon p, where p is the momentum of particle mv. Heisenberg uncertainty principle: it is not possible to determine the position of and velocity simultaneously for the subatomic particles like electron at any given instant to an arbitrary degree of precision. Consequently, it is not possible to talk the path of the electron in which it moves. If delta x is uncertainty in position and delta p is uncertainty in momentum, then delta x dot r delta p is greater than or equal to h upon 4 pi. Orbital: it is a region or space where there is a maximum probability of getting electron. Quantum members: they are used to get complete information about electron, that is, location, energy, spin, etc. The quantum numbers also help in designate the electrons present in the orbital. Principal quantum number: it is principal quantum number if it specifies the location and energy of an electron. It is measure of the effective volume of the electron cloud. It is denoted by n. Its possible values are 1, 2, 3, 4. Angular momentum quantum number: it is also called azimuthal quantum number. It determines the shape of the orbital. It is denoted by I. The permitted values of L is equal to 0, 1, 2, etc. Up to n minus 1 for the given value of n. L is equal to 0 and 2n is equal to 1, n minus 1. Example: if the value of n is 4, L can have values of 1 to 3, 0, 1 to 3. It determines the angular momentum mvr is equal to under root L on L plus 1 h upon 2 pi. Magnetic quantum number: it is denoted by m, and its value depends upon the value of on the L, since Magnetism is due to angular momentum. It determines the magnetic orientation of an orbital, that is the direction of orbital relative to magnetic field in which it is placed. Its permitted values are -1 to +1, including 0. Example: when L is equal to 1, then M is equal to -1, 0, +1. It has a total number of values equal to 12 plus 1. Spin quantum number. It indicates the direction in which electron revolves. Spin is a magnetic property, and it's also quantized. It has two permitted values of plus half or minus half. A spin angular momentum of an electron is a constant and cannot be changed. Next point, plus n plus 1 rule. The relative order of the energies of various subshell in the multi-electron atom can be predicted with the help of n plus 1 rule, also called the Bohr-Bury rule. According to this rule, the subshell with the lowest values of n plus 1 has lower energy. In case two subshell has equal value of n plus 1, the subshell with lower value of n has lower energy. Pauli's exclusive principle. No two electrons in an atom can have all the four quantum numbers same. It can also be stated that an orbital can have maximum two electrons, and they must be of opposite spin quantum numbers. Aufbau principle. Electrons are filled in the various orbitals in the increasing order of their energies. That is, orbital having lowest energy will be filled in first, and the orbital having highest energy will be filled last. The increasing energy of atomic orbitals for multi-electron atoms: 7s is greater than 6p 5d 4f, 6s 5p 4d, 5s 4p 3d, 4s 3p 3s, 2p 2s 1s. Hund's rule of maximum multiplicity. The no electron pairing takes place in p, d, and f orbitals until each orbital in the given subshell contains one electron. Example: n is equal to n7 has electronic configuration 1s2, 2s2, 2py, 2px1, 2py1, 2pz1. According to Hund's rule, and not 1s2, 2s2, 2p2, 2px2, 2py1. The valence electronic configurations are of Cr and Cu, chromium and copper. Therefore, are 3d5 4s1 and 3d10 4s1 respectively, and not 3d4 4s2 and 3d9 4s2. It has been found that there is extra stability of completely filled and half filled subshells as associated with this electronic configuration. 3 orbitals of 2p subshell, 2px, 2py, and 2pz orbitals. 5 orbitals of 3d subshell: 3dxy, 3dyz, 3dxzx, 3dx minus x square minus y square, and 3dx square orbitals. Structure of atom. Please like, share, and subscribe. Thank you so much for watching.